Okay, in reprofiling a set of skates on the Prosharp machine, once you've already profiled a set of blades and you want to do it again, you need to go ahead and put the skate in a slightly different position. I want to show why. When you're reprofiling or profiling, this mark on here, which is a 20 millimeter pitch on this Zuperior, this is a Zuperior that has a pitch on it of 20 millimeters. This always has to line up with this, whether it's profiling or reprofiling. The whole thing about doing the shift is not trying to get, this always has to be lined up with this when you're doing profiling. What you're trying to do is make sure this doesn't have a added twist to it, and that's why with the tooling pins on here, originally you're between the two here with a brand new blade, and then later on this is the low point, so you've got to go ahead and have it right here between the rollers. It's got rollers on the older model, it's got a ball bearing on the new one. So originally it's on here. You reprofile a year later, this has got to line up with this to hold it on the rollers, and you hold this in place and you move the sledge so it lines up like that. Then you lock it down. Just about got that one right. Okay, in reprofiling a set of skates on the Prosharp machine, once you've already profiled a set of blades and you want to do it again, you need to go ahead and put the skate in a slightly different position. I want to show why. It may not be obvious. Just for review, the templates that are multi-radius, Zuperior, Quad, and Ellipse, they have a pitch bias anywhere from, a lot of them are 20 millimeters minus, and the smaller ones are 12, 15, and 17. It's called pitch, but this is an offset. And for review, once you put a template in the machine and you cut a skate, the lowest part here is this dimension called the pitch dimension, and it's toward the heel. And on the older AS 2001, it has a set of rollers to reference the blade, and the newer one, the SC model, it has a set of balls to reference where the blade is. And that's critical when you're doing profiling. If you're just going to cut a set of skate blades here, you're going to go through and just sharpen it. Let's say you first just had a parallel blade and you stuck it in here. This could be back and forth a little bit this way, and it's not going to make any difference where that is. If you took a single radius blade and you dropped it in here like this and exaggerated, if it was against the reference points down there, if it was up like this, just a slight angle, let's say it was off 1/4 of a degree, all that's going to do is that when this machine's here, it's going to go a little bit higher on the toe here versus the heel, and vice versa, because you're not profiling. The template is off the machine. So when you're using a template on here and you're grinding a profile, it's really critical the skate is at a defined location. And so the tooling points are this down into here. So if you put a brand new blade in, you found the center, you put this down here where the pivot point is, you go off and then you profile the blade. This particular one I've got in here now is Zuperior M, and it has a low point here of 20. So 20 millimeters back. This is the heel, this is the toe, this is the low point. So after it's cut on this blade, the lowest point is going to be 20 millimeters back here. Now, whether this is on the skate or not, let's say later on you want to go through and you want to go through and reprofile this a year down the road because it's got some degradation. When you put it in there, if you just put it in here like this in the center, it's going to have a pitch to it, which you don't want. So you want between the rollers to be the lowest point on here. So if you look down in there like that, I've gone through and drawn, let's say a lot of these are 20 millimeters, it's over to here. So if you took a blade, here I've done this with the foam core to exaggerate it. Here's a multi-radius one, and this radius here is almost about a meter. If you put this in here like this to start, it's going to go ahead and cut this, so instead of this being the low point, it's here. So after you've done this, if you want to come back, say half a year later, you need to put this in to where this lines up in the pivot point, because that's going to register on the rollers an equal distance from the lowest point. So it's got to be like that in there. That's so this is level, so that the distance between here and here, lowest point in the rollers, is the same. Now, this I've got it drawn is each one of these blocks is 5 millimeters. So this is 10, 20, 30 millimeters, 10, 20, 30 millimeters. So on the rollers, if you had this set up in the older machine so that like that is the pivot point here, so the rollers are equal distance between this, you would want to put the blade after it's been profiled. Instead of putting it here, you want to bias it over here. That's so this is level. If you actually put it in here like this, see, it's at an angle. You don't want this. That's not right. So you're going to get all screwed up if it's like that. So by biasing this over on here, now this is defined on either side of the bulge. So it's contacting here and here. Then if you go through and look at a blade, the smaller radiuses on here, the XS Zuperior, the small ones that are for small skates, they have a smaller bias number, 12, 15, and 17. So I've got an example over here which is only 15, and that's going to be a smaller one. So when this is originally in here, before it's cut, it's going to be like this level. So if you went through and you sharpened, put a template in here, and you cut back and forth, and you had, which one is that? Zuperior XS. I don't know if I've got one that small. But instead of having a 20 on there, it's got a 17 or 15. So after this has been profiled, if you unclamp this and push this down, it's going to be tilted. So the rollers on this are just used initially to do a reference, and when it goes back and forth and cuts on here, it's no longer going to touch the rollers because you're cutting away material away from this. So once you're cutting, the tooling points are now, there's a gap between here and here because you're cutting material. So if you cut a blade like this, put it in here, to begin with, the blade is going to be level like this. With a brand new blade that's out of the box. It's going to be, because blades are centered so that the radius of curvature is generally 3 to 4 meters, and it's to where it's in the center. So this is going to be level, parallel. Now after you cut it to this, the bias point, the lowest point is to here. So if you unclamp this magically, and you push this down, it's going to have a tilt to it. So later on, if this is on the skate, and then later on you want to go through and reprofile it, you're going to put the skate in here, and you're going to have to bias it forward so that this dimension here is actually at the pivot point that's between the two rollers when it's clamped down, like that. And that is before you clamp it. I have to be careful what I'm saying here. That's before you clamp it on here. That's to get the thing level. Then the sledge has got to be moved over by this amount. Then it's clamped down. So you hold this in position here like this before you clamp it. And then this will match onto here. So this is really a tooling issue if you want to look at it, in the sense that it's in here to begin with on the rollers to get this level. And then you're going to move this by hand, hold the skate, and move this forward such that this point is going to line up with this over here. And I think on one of the Prosharp videos they do that. So if this skate was on here like this, and that's the original cut on it. Once you've gone through and profiled, and a year later you put the skate in there, you have the 20 millimeters on there, you're going to go bias this over. Then you've got to go through and move this back, hold the skate and move this to where this stays on the same rollers, and then this lines up on the point like this. And I shouldn't really have the template on here right now, but that's so that it's still touching this, but then you've clamped this down. So the idea is you want to have the skate so that it's in the correct position, and then you're going to go through and move this over and clamp this down so that this new, if it was 15 millimeter, let's say it's 20 on this, this has still got to line up to the low point over here, which is not the center anymore. But if you just go stick in there, normally what's going to happen, you're going to have a pitch bias like this. It's going to be one of these ways, so you're going to get screwed up. So that's the purpose of this dimension here. In one of their videos, they kind of quickly go through that, and I wanted to just kind of go through and explain this so that maybe it kind of made more sense. So this is on the original skate. You're cutting it. It matches to here, so now the low point is over to here. Maybe a year later you're going to profile this again. You're going to have to put that mark on here to this. So if it's on here like this, put the skate in, it's been profiled, you take it out. A year later you're going to put this in here, and you're going to put it like this. So it's between the two rollers. Then you have to hold this skate in position. And it's going to stay in that position because it's tied to the rollers. Those rollers are fixed to the frame here. They're not fixed to the sledge. So on here you have to hold this in place, and maybe I need to put this on a tripod and show. Hold the skate in place so it's fixed to the rollers, and then scoot this over so it lines up onto here. Okay, on the original profile with the new blade, you use the center of the blade here. Put it in the machine where the pivot point is. You've got your two reference rollers between the two. You put it in, lock it down, you profile back and forth. The template I've got in here has got a 20 millimeter back bias, which means the low point after profiling is back this way. That's a Zuperior. Okay, so this template on here cuts this onto the profile on the skate. So once that's all done, you go through and you put the radius of hollow in and whatever to get it to be sharp. So now the new radius on this, it's got this 20 millimeter back portion, so the max bulge is here. Now once you've used this skate for, say, let's say a year, so many sharpenings, if you want to go through and reprofile it again, you've got to use a special technique to put it in the machine. You go through, and instead of putting this on here like this in the center, if you do that, the blade's going to have a tilt to it like this. So you're going to get screwed up. So what you got to do is you got to use the new, this is the new low point. So you put that on the tooling on here like this. So that means the skate is level. If you got it like here, it's going to be tilted too much like this. So you got to go ahead and know what the profile is, and this has got a 20 millimeter pitch on it. So for reprofiling, you put this in here between the two rollers, or the new one's got balls. Then you don't lock this down, you just hold this in place. Then you've got to go scoot the sledge over to where the pivot point marches up to the center of the skate. So that means that this point here lines up with this. And I'll show that just in a second from another view. Okay, I've got the sledge here, the pivot point between the two rollers. Originally, new blade, you put this on here between the two rollers, clamp this down, you profile it. And if you reprofile it again with a multi-complex radius that has this 20 millimeter back pitch on it, you can't just drop this in here, because what will happen, again, if you put it in just like before, what's going to happen is it's going to go through and have a tilt to it. So you've got to get this between the two rollers. So the rollers need to be centered around this new low point. So you go through, put that on the low point like this, but this point on the template has to match up to this. Let me bring this down here. So on the template there's a mark over here, and okay, when you're reprofiling or profiling, this mark on here, which is a 20 millimeter pitch on this Zuperior, this is a Zuperior that has a pitch on it at 20 millimeters. This always has to line up with this, whether it's profiling or reprofiling. The whole thing about doing a shift is not trying to get, this always has to be lined up with this when you're doing profiling. What you're trying to do is make sure this doesn't have a added twist to it, and that's why with the tooling pins on here, originally you're between the two here with a brand new blade, and then later on this is the low point, so you've got to go ahead and have it right here between the rollers. It's got rollers on the older model, it's got a ball bearing on the new one. So originally it's on here. If you reprofile a year later, this has got to line up with this to hold it on the rollers, and you hold this in place and you move the sledge so it lines up like that. Then you lock it down. Now, right now that this key exactly matches up with this, but it doesn't have a tilt to it. If you go through and you do it the other way, you're going to have a tilt back and forth on this. Because if you take this skate and you just run it through here, again exaggerated, if you take this on here like this and you put it like here, it's level. If you go through and you put it the wrong place, it's either going to be pitched up or pitched down an angle. So I probably exhausted this, but I had to go through this myself just to understand what was going on. So in summary, this is always going to line up to whatever you have on the skate. You're just shifting this back and forth so that the tooling points on a new blade, you got it between the center because that's where the rollers or the balls are. Now once it's reprofiled, you want to be between here so that doesn't have any tilt. If you put it here, what's going to happen is it's going to have a tilt down like this. The skate's going to be biased down. If I zoom out here. So if you do it the wrong way, you're going to add an extra pitch this way to it, which you don't want to have. So, and then on those tooling surfaces, after you've done a little bit of profiling here, one pass, it's no longer going to touch the either the balls or the rollers on there because you've cut